obviously. There's a tick there. Okay. Are you all good for me to start explaining?
Yeah.
Cool. So we have 79.3 kilograms. And if we were to write that in grams, it'd be 790. Would that be 7? Would it be like this? Wait.
I think it was 79.03.
0.03.
I'm not sure, but yeah.
79. So it'd be like that. Okay. I don't know why I wrote that. Like that. Okay. Grams. Okay, so if we're in kilograms and the smallest unit of measurement would be this point here, the 3.
Yeah.
And the 3 is in like that's in like grams, right? So that's why I like take it to grams. Does that make sense?
Yeah.
Like I don't know how to, because it's in that position. So it's like it'd be 79 kilograms plus 300 grams. Does that make sense? 79.3 kilograms. Does that make sense, that part?
Yeah.
So the smallest unit of measurement in the 79.3 kilograms is grams. Is that cool? And then to figure out where it is. So it's sitting, if this is the 10, this is the ones position, this is the tens position, this is the hundreds positions. Is that cool?
Yeah.
And so if this is the hundreds position, where the 3 is sitting is in obviously the hundreds position, and absolute error is half the smallest unit of measurement. So the smallest unit of measurement in this question is where the 3 is, and 3 is in the hundreds place. So the smallest unit of measurement is 100 grams, and so half of 100 grams is 50 grams. Are you able to hear?
Okay.
Because I don't know if my internet's been silly.
No, I can hear you.
Okay. But yeah, it's just like, it's understanding what the smallest unit of measurement is. That's the hardest part. Because once you find the smallest unit of measurement, it's just half that. And so it's 50. Because there's no number in the 1 section, and there's no number in the 10 section. So the smallest unit is the 3, which is in the hundreds section. Does that make sense?
Yes.
And so then if the smallest unit is like a lot of 100, so it's like 100 times 3, but like the smallest unit is 100. And so it's half the smallest unit. So it's 50. Okay. So this is, the absolute error is half smallest unit of measurement. Is that, like, are you cool with that definition? I think you'd be cool with it.
Yeah, I am. I just is it always going to be grams?
No. So it could be centimeters. Like they could have a ruler and they could have like 10 centimeters, 20 centimeters, 30 centimeters, or whatever. So it could be in centimeters, it could be grams, it could be any unit of measurement. And it's just like the smallest unit of measurement. It could be like,
How do I know what the smallest unit of measurement is for it?
so there's two ways to do it in this question. So you could just put zeros where the numbers are, and then add a 5 on the end. So for example, like 2.4, you could just do 0.05, put zeros where the numbers are, and then add a 5 on the end. So that will give you the absolute error for 2.4 centimeters. Or you can do half the smallest measurement. So the smallest unit of measurement in here, if we have 2.4 centimeters, the 2 part is centimeters and the 4 is millimeters. Is that cool? Because if you have a look at, look on a centimeter ruler, where is it? Here, and you go along to 2.4, you've got 2 centimeters and then plus 4 millimeters. Is that cool?
Yeah.
2.4. And so the smallest unit of measurement for 2.4 centimeters is 1 millimeter. Is that cool?
Mm-hmm.
And so 1 millimeter in terms of centimeters equals 0.1 centimeters, which equals, it's 1 millimeter. And so if that's our smallest unit of measurement, you can just do 0.1 times half. And if you put that into your calculator, it will give you 0.05.
Okay.
So
I kind of get it.
You kind of get it?
Yeah.
Cool. So it's just when you're doing ones like the centimeters one, you can just put zeros where the numbers are, and then add a 5 on the end. Or you just find the smallest unit of measurement and times it by half. Is that okay?
Wait, so what's the one in red?
So the one in red, let me type it up.
Do I just go 0.05 under it?
We have, and you put zeros under the numbers and then add a 5 on the end. So 2.4 under the 2, add a 0, under the 4, add a 0, and then put a 5 on the end. Does that make sense?
Okay. Yeah.
Like where you're given okay, let's do another example. Let's do, let me get the color up. Okay. Let's do down here. 1.523 millimeters. Okay. And so if we're doing the red one, you just put a 0 here, 0, 0, 0, 5.
Got it.
You just put 1 with that 0, 5 with that 0, 2 with that 0, 3 with that 0, and then add a 5 on the end. Is that cool?
And then that's the answer?
Yeah, that would be the answer. So that doesn't work.
Oh, that's easy.
Wait, let me see if it works for the other one. 79.3 kilograms. 0, 0. Oh, actually, it kind of works. Okay. So let me I'll screenshot that. Okay, the other one in that question that you just guessed but got right, it was 79.3 kilograms.
Mm-hmm.
And so if we do that, the red rule where you just go 0, 0.05, is that cool? Put a 0 where the numbers are, and then add a 5 on the end.
Yeah.
And so if that was, like we know that this 3 is in the hundreds place. I think we were talking about that before. If it's like 79300 grams, that 3 is hundreds place. Is that cool?
Yeah.
And so where would our 5 be if it's the one before hundreds? It'd be in the tens place. Because it goes ones, tens, hundreds. And so if the 5 is in the tens, then it'd be 15, because 5 times 10. And so that's like how you do that one. So it'd be 50 grams for that one.
Okay.
So if that red rule works easier, I don't know. Does it make sense?
Yeah.
Kind of? Yeah?
Kinda, yeah.
Okay. But I think the hardest part is understanding what the smallest unit of measurement would be.
Yeah.
And so if you're on a centimeter, it's kind of easy to visualize it. If you're like on a centimeter ruler, okay. So we have each big number is like a centimeter, right?
Yeah.
But the smallest unit of measurement on this ruler would be where these little dashes are. And that's the what are they? Millimeters.
Yeah.
And so that one is kind of, so if the marker was at like 3.4 here, and they said, what's the smallest unit of measurement for 3.4? It's kind of, it's pretty easy to think like the smallest unit of measurement on a centimeter ruler would be millimeters. Is that cool?
Yeah.
Each millimeter is like 0.1 centimeters. So 0.1 times a half is just 0.05. But yeah. So it's just finding the smallest unit of measurement and halving it for absolute error.
Yeah.
Yeah. Any other questions, or like, does that make sense? Or
Yeah, no, that was good.
okay. Okay. You don't know how they got C, is it?
Yeah.
Let me share my screen. How do I? Okay, so I've got it here. So what did you do? Well, I'll go through it with you. Okay, let me rewrite it. So it's 3x minus 4y minus 4y equals 0.
Yeah.
And so the first thing I would do is probably take the 1 over. So 3x minus 4y equals 1. Is that cool? Because
Yeah. Oh my gosh.
yeah,
Sorry.
that's fine. That's good.
Yeah.
And then I would get rid of this 3x. So it'd be negative 4y equals 1. And then it would be minus 3x. Is that cool?
Yeah.
Because what did we do? We took 3. And then you want to get the y by itself. And so if you want to get the y by itself, you have to get rid of
Sorry. Okay.
Divide by 4. So then it's 1 minus 3x over 4. And then when you've got the y as a negative, you can go across and change the symbols of the other side to erase the negative on that side. Does that make sense?
Yeah.
So then I'll do, so then it's y is negative 1 plus 3x over 4. Is it cool how I went from step 3 to step 4? Does that make sense? Where you can take the negative across?
Take the negative across. Yeah.
Yeah. And so when you erase the negative from this side, you just have to change the symbols on the other side.
Yeah.
It's a negative. So then it'd become negative 1
I don't know where I went.
plus 3x over 4. And when you have a negative number out the front, you can literally just swap them over. So it'd be positive 3x minus 1 over y. Because these two are the same thing.
Okay. I'm just copying that last step down.
Yeah. That one in yellow is the same as that one there in green.
Okay.
It's just like a more correct version.
Okay.
Are you cool how I went from the yellow to the green?
Yeah, I don't know what did you do with the 1 and like you changed it. Because the thing is, that's why I have like dashes next to B and D because I thought it was plus.
Oh, plus 1.
Yeah.
Okay. That's just because that's from when that's in step 3. You forgot to take the negative y over.
Right. Okay.
And so, well, like the negative across. And so you're left 1 as a positive and you left with 3 as a positive. But you've got to get rid of the negative that is there too. Because negative y is different to y.
Okay.
And so if you have a negative y and you're trying to get y by itself, you have to remove the negative.
Okay.
So you have to take it across to the other side. And so you just change whatever symbols are there. So that's why it then becomes a negative 1 and you change the negative 3 to a positive 3.
Okay.
Let me know when you're good to go.
Yeah, I'm good.
Okay. So you have the reference sheet with you?
Yeah.
Cool. So if we're looking at the volume of a bowl, which is just the volume of a sphere.
Yeah. Is it pi r squared?
Pi r squared, that would be the area. Pi r squared equals the area of a circle.
Okay.
In a sphere. So this is a 2D shape. the pi r squared is 2D shape, and we're in like a 3D shape.
Okay.
So a circle would just be like that, but because we have like not just like a 2D shape, we have like a physical 3D shape. Does that make sense? So they're going to have different formulas.
So where's it's right there, volume.
Yeah, volume, and we want the one that's a sphere.
How do I know which one's which?
Okay, so you'll just have to.
Have you seen my reference sheet? Yeah, see like where it says volume?
Mm-hmm. Cool. So you'll just have to memorize them. But the numbers with the 4 in them are the spheres.
Okay.
And this one, the 1/3 AH, I think that one is for a pyramid.
Okay.
Or a cone. I think it's a cone. And so if you remember that the 4s are the ones with the sphere. So that would be the area of a sphere. And this one would be the volume of a sphere. So
okay.
The formulas with the 4 in them are the spheres. And then,
Okay.
like if you just annotated a reference sheet, you could just memorize that the spheres are all the second ones there. If that makes sense.
Yeah.
If that's 1, that's 2, that's 1, and that's the second ones are the spheres. Okay. So our formula is 4/3 pi r cubed. And so we can just sub for the volume of a sphere. So volume equals 4/3 pi. What would our r be?
The radius?
Mm-hmm.
I don't know what it is though, because it doesn't say.
So if a diameter is all the way across and radius,
it was a big half, yeah.
what would it be? 8?
Yeah.
Times 8 cubed. And so we can just put that into our calculator. So 4/3 times pi times 8 cubed.
Do we not put the 16 in anywhere?
No, so the 16 is just there to tell us what the radius is without directly telling us what the radius is. Does that make sense? It's just another tricky thing. So someone might come to this question and put 16 as the radius, but they have to know that 16 equals diameter and radius equals half diameter. And so did you get this answer in your calculator? You should get that answer.
Yeah.
And so that's the answer for a sphere, but we're doing a hemisphere, which is half a sphere. And so we just have to divide that into by 2. And so divided by 2 equals 1 centimeter. Is that all good?
Yeah.
Dropping it down.
So, yeah. So, and then how on the reference sheet?
Mm-hmm. I'll go back to it. Oh, yeah.
So everything in the surface and volume is a sphere,
Mm-hmm.
and then the top 2 are pyramids.
the top one here, that would be the area of a cylinder.
Okay.
So the you know how a cylinder like has that's a really bad drawing of a cylinder. But you know how like a cylinder has this surface?
Yeah.
And then this surface, the two circle surfaces?
Yeah.
You know how you said before the pi r squared one?
Yeah.
And we said that was the area of a circle. If we have two circles in a cylinder, then it's going to be 2 pi r squared. That's
right. What does the h at the end of it stand for?
That's the height of the cylinder.
Okay.
Yeah.
Can we actually also go through this sheet and like name what everything's for?
Yeah, let's do that. We'll do that also. And this one, I'm pretty sure that one's for a cone. Let me just search it up quickly.
Okay.
Because I want to be...
Because I think I'll like memorize that and then study that as well.
You'll know like where each thing was. I just have to find it. Okay, I'll be in year 11 textbook. But actually, no, I should have it in here. Okay, I'll be 2 seconds. I'm just going to grab it.
Okay.
Okay. Let me grab it. Yeah. Okay. 194. Hang on. Okay, let me clear this then. Wait. Are you all good with this answer here?
Yeah, I got it.
Cool. I can clear that. Okay, I don't know. All right, so we've got this one here is sphere. This one here is sphere. That one there is cylinder. This one is trapezoidal. This one, okay, this one here is, that one's Z scores, we know that. AH. Volume equals...
Did you write what's 2 scores?
Oh, Z scores.
Oh, sorry.
Z scores. This one is a cone. And I think it's also a...
I thought that was a pyramid. Oh, okay, yeah.
I can like send you photos of them all as well because I have them here.
Trapezoidal.
And then We already know the spheres. That one, the area. That one here is trapezium. This one is sector. Okay.
What sector?
So that's like if we had a circle and
Right.
this part here, they asked us to find that part, like the area of that little circle there.
Oh, okay.
And so here it would be like, I don't know, 70 degrees, and the radius would be 3. And so then the formula for that one would be 70 on 360 times pi times 3 squared for that
Okay.
of that sector. So if it said find the area of the sector below or something, then you just use that one. Okay, is there any more? Am I missing any? Okay, the length. That length is, okay, can I, have you got these ones down? This one here.
Yes.
Okay, so I can clear those. What have we got up here? Okay, this one is compound. This one's depreciation. That one's straight line depreciation. So it kind of says it in the heading. Okay, absolute error. This one, I think, that one, I think, is the length of a sector. Yeah.
Oh, look, it has absolute error up the top.
Mm-hmm. Or maybe that's the arc. I'm not too sure. Okay, and then now these ones down the bottom. Do you remember what each ones are for? This one here. Do you know what that one's for? Ooh.
Area?
Yeah. So area of a non-right angle triangle. This one here is our sine rule. And these two are cosine rules. this one up the top is for a side, and this one down the bottom is for an angle.
What is a cosine rule for again?
So that's when you have a triangle like that, and you know how you might have like an angle down here and a side across there, and maybe a side here, and you can go across and across, and that's the sine.
Yeah.
It's when you can't do the sine rule, and so you might have oops, oh well, like that, and so you have nothing
Right.
to go, like you have nothing across it, so you can't do the sine rule, and so you have to do the cosine rule.
Right, okay.
So when the sine rule doesn't work, so if you're ever doing like a problem for a triangle and you attempt to do the sine rule and it doesn't work, then try and do a cosine rule.
Okay.
And let me get y. So cosine rule, this for a side is when cosine rule, when you're given, I'm just going to type it up. So you use it when you're given, wait, which one's which? Yeah. For, I'm going to write it up here. For cosine side given two sides and an included angle for an angle where you are given sides and no angle. Okay. So hopefully that makes sense. That's when you use the cosine rules. So if you have 3 sides and no angle, you use the cosine rule to find an angle. And if you're given 2 sides, like 17 and 16, and then an included angle in between the 2 sides as like 63, then you can use the cosine rule for a side.
Okay.
Okay.
I'll let you guys keep working.
We'll probably go for another like 10 minutes.
Yeah,
or so.
go for as long as you need to.
Yeah. There we go. Okay. So is that your whole reference sheet annotated now?
Yeah, just a question. What's the one at the top?
Let me clean.
Like the length.
Oh, I think that one is a sector or an arc. Arc.
Yeah.
The length of an arc, which is, you know how before we went through what a sector was?
Yeah.
This part here would be the arc, right?
Right, okay.
Right.
Yeah.
Yeah. So that would be the arc. So if you're trying to find the length of like the curved part of the sector. So it's like the area of the sector was, I'll do it in yellow.
So it's kind of like the arc is the crust.
Of
Yeah.
the pizza.
Yeah.
Yeah, that's right.
Yeah.
And the sector is the slice.
Yeah.
Okay, cool.
Cool. Okay. So that's the whole reference sheet done. Is it?
Yeah.
Yeah.
Okay. So did you want to go through the rest of those questions or some of the questions you sent?
Yeah, sure.
Which one would you like to go through?
Do you want to go through that one?
17?
Yeah.
And you'll be able to use your reference sheet for it now.
Okay.
So could we use the sine rule for it?
Yeah, that's what I was thinking. Oh, but like you can't because you have to use the cosine rule.
Yeah. So we're using the cosine rule. And which one would we use?
For side?
C squared or, yeah, so we'll use the side one, which is the C squared one, isn't it?
Yeah.
So we're using C squared equals A squared plus B squared minus 2AB cos C.
Okay.
And our X is going to be our C, because that's the side we're trying to find. And so
Yeah.
this would be A, this would be B, and this is cos C. Is that cool?
Yeah.
So C,
So does the A point to the B?
the A and the B. What about
Yeah.
O? What did
You know how I drew an arrow from 80 to C?
Mm-hmm.
Where does the other pointer go?
So we can't use the sine. So the sine rule is the one where you do the arrows.
Right, okay.
And this one we can't do arrows.
Oh, right. No. I would have guessed that. That was a dumb question.
And so A and B are interchangeable. So they
Yeah.
could be 13 could be A or 13 could be B. It doesn't matter. So it's 11 squared plus 13 squared minus 2 times 11 times 13 times.
Do you have? Sorry, I forgot my calculator. Let me get it.
And then pop it in the
Sorry.
That's all good.
I feel like I'm actually like a bit confident about the maths test.
Yeah. You've done lots of study, Amy. You know how to do stuff. It'll just be like remembering to do that, if that makes sense.
No, like that's literally my problem.
Yeah. Like you'll see a question and you know how to answer it, you just can't remember.
Yeah, I know.
But you'll be fine. Just get in the test and just be like, think. Can I use a sine rule? No. Can I use it?
But I feel
Yes.
that will help.
Yeah, that's good.
With the cos C at the end,
Mm-hmm.
do you know how I go like 11 then times 13? Do I go times cos C?
Yeah. Yeah. And when you press cos, it will come up with like cos like bracket. And so just pop in 80 there and close the bracket.
Oh, okay.
Did it come up like that?
Yeah, that's why I had to redo it.
You should come up like, I don't know if you can, how do I show you? There. Cos bracket.
Did you get 2440.3?
Mm-hmm.
Okay, cool.
But we have to do one more thing.
Oh no, what?
Have a look. Is C by itself? Or is there a square root attached to it? A square sign.
Not C squared.
Yeah, so we have to get C by itself. So we have to get rid of the square. So you have to do square root of 240.
Okay. See, I'm so gonna forget that.
Then you should at least get 2 marks. You'll get 2 out of 3.
Do you get 15.5? Okay, cool.
So if you're doing a question like this, just when you come to the end, just say, is my C by itself? And if it's like
Yeah.
then you've completely like done it. But if it's still the square root sign, the power of 2 there, means you'll just have to do one more step.
Okay.
Is that one all good?
Yeah, that one's good.
Awesome. Okay. Do you have an answer for it?
Yeah, but you know how what it says in its simpler form?
Mm-hmm.
You can't halve 25 without it being 12.5. Does that matter?
So if it comes to that just means there's a different number other than 2 that we'll have to go into. And so
right.
I think
I have to do that for them.
Yeah. So you have to think of a
Okay.
number that could go into all of them. So if you did think about 2, you could get 15 and then you could get 20, but 2 wouldn't work for 25. So you're correct. You have to choose a different number.
Okay.
Which number do you reckon?
I went with 5.
Yeah. And so divided by 5, divided by 5 equals 6, 5, and 8.
Yeah, I got that too.
Cool. That is correct. Okay.
Cool.
And then have a go at doing the next one and then let me know.
Okay. Wouldn't you just go 19 plus 36?
No. So, you know how we simplified from that to that?
Yeah.
Simplified. Okay. So if you put in your calculator 6 plus 5 plus 8, it should equal 19.
Oh, yeah?
And so that gives you a hint that this simplified version of 19 is the simplified version of Andrew, Brandon, and Cosmo's runs. And so the 36 is the simplified version of the whole team runs. So 19
Right.
and 36. So 19 is equivalent to the 6 plus 5 plus 8, which is, and so if you add those up, 30 plus 25 plus 40 equals 95. And so I just added the 30 plus 25 plus 40.
Yeah.
And so instead of going from dividing by 5 and to simplified, we have to go from simplified back to the runs.
Got it.
And so from 19 to 95, what's the factor between those two? So if you just divide 95 by 19.
5?
Yeah. And so if from 19 to 95 is 5, if we times 36 by 5, it should give us how many runs were scored by the whole team. So 36 times 5 is 180. So you know how we divided by 5 up here? In the first,
Yeah.
up here? We're doing the same, but instead of going like that way, we're going the other way. We're going back way, and we're timesing by 5.
Got it.
Is that one cool?
Yeah.
Awesome. Okay. And let's go down to this one. Okay. We'll do this one. Oh, so this one we'll have to find, I'm in yellow still. We'll have to find Q1, Q2, and Q3 and IQR.
Oh no. What's Q1, Q2, Q3?
It's the five, well, it's 3 of the 5 number summary. You know how you find the middle one and then you find half of the other half? You're pretty good at this if you remember. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, that's our range, right?
5. 1, 2, 3, 4. So it'd be 192.5 for Q2, Q1, Q3. Do you remember now?
Yeah.
Cool. Is this all good? Is it ringing any bells? Are you getting reminded of it now? Kind of, maybe? Do you remember this red stuff?
Yeah.
Splitting up
So
the-
it isn't out.
Yeah?
Yeah.
And then, so we have to figure out if the shortest player, which is 170, because that's the shortest, is an outlier. And so have a look on your reference sheet at your outlier formulas. Which one would we use?
Do we go 185 minus 1.5 times 9?
Yeah. Correct. And so what we would get? We get the answer of 171.5. And so you know what that answer means?
Means that it is an outlier.
It is, yeah. So anything below 171.5 is an outlier. Therefore, 170 is an outlier. So does it make sense how we get these numbers here and why we get those numbers there?
Yeah.
Q1, Q2, Q3s. Cool. Anyway, okay. Do you want to have a go at doing this one?
Yeah.
What you could not do? Yeah, we go.
Why does it say? It says it has the numbers 1 to 36, and it says where each of the 37 numbers is.
Yeah, because they're counting. Yeah.
Okay.
So 0, 1, 2, 3. Yeah.
Is there something about frequency on the sheet?
I wish there was, but it's not. This stuff is from year 11. So there is a formula for expected frequency, or you could just kind of like do it in your head kind of thing.
Yeah.
And so I would probably say, well, if we're trying to spin the number 8, what chance do we have of spinning the number 8 if there's 37 numbers? Like, would it be 3 on 37 or 2 on 37 or? Does that make sense?
Yeah. Like something.
Numbers are on the wheel once. What do you mean? Oh, 1 out of 6 times. Yeah. Like if you roll a dice, the chance of getting 2 is 1 out of 6 because there's 6 sides. So the chance of spinning the wheel and getting an 8.
I swear we did this last week and I already forget.
It would just be 1 on 37. Because if each of the numbers are equally likely to be spun, that means that all of them are ones. And we're just trying to spin one number 8.
Is that it?
So it's 1 on 37 is how likely it is to be spun. And then if we're spinning it 18,500 times, we just have to times it by 18,500 to figure out the frequency of it.
Okay.
And so the likelihood of spinning an 8 is 1 on 37 if we were to spin it once. And then if we're to spin it 18,500 times, we just have to times it to figure out how many times we'll actually spin it.
Okay, well, I got 500.
And so that's the answer. It's 500.
Okay.
So there's probably 1 mark for getting the 1 on 37 and then 1 mark for getting the answer.
Okay.
Yeah. Okay. Let's have a look at the last one. Okay. Do you remember the dividend yield formula? Or I'll give you time to read.
No.
Okay. So for this one is not on your reference sheet. So you do have to memorize it.
Okay.
Dividend yield equals dividend over market price, I'm pretty sure, times 100. Is that right? Cool. 100%. And then we can just sub the numbers into the formula. But I think there is a trick. There's an own.
Yeah, the amount of shares.
Okay, have you copied down the formula? Almost.
Yeah.
Cool. Okay. So this one, some of the dividend yield questions like this would be really nice and you can just like sub them in. But with this one, the market value is in terms of per share. But the dividend is like the total for all of the shares. And so we just have to convert the dividend to per share. And so we just have to divide the total dividend by the number of shares to get like for 1 share, dividend price for 1 share. Is that cool? Does that make sense why we're doing that?
Yes. What about the times 100% thing?
So we'll do that in a second.
Okay.
So we've got a market value of $8.75 per share. And then this will give us 0.7 dividend per share. Because the $1,068 was the total dividend for all the shares, but if our market value is in per share, we have to convert the total dividend to per dividend for each share. Does that make sense?
Kind of, yeah.
do you remember when we're doing like kilowatts and kilowatt hours?
Yeah.
And if it's not in the same, if like the money is in kilowatt hours, but the electricity is in kilowatts, you have to convert the kilowatts to kilowatt hours to make sure they're on the same.
Yes.
So it's similar to that. Because the market's in per share, we have to make sure the dividend is in per share as well.
Okay.
And so once they're in the same like units of per share, then you can sub in the formula. So then it will be 0.7 over 8.75 times 100%. So it should give you 8%.
What's the 8 points? Oh, wait, it's the price. Sorry.
And dividend yield will always come out in a percentage.
Okay.
So does that one make sense now?
Yeah.
Normally, they will already be like in the same terms of per share or whatever, so you might not have to change them, but you just have to, like, you know how when you're doing kilowatt hours, you just have to check that they're all in the same units? It's just the same thing.
Yeah.